This is Mark Anderson for Kellogg Community College, and we're going to be looking at 6-word problems, story problems involving quadratics. And we're going to start off with our first two today to do some kind of interesting translation. It's going to start out by saying, find the two numbers whose sum is 50. Okay, now let's just take that first part here. The two numbers whose sum is 50. And let's use x and y for the two numbers whose sum is 50. Now that means these numbers could be like 10 and 40, 20 and 30. They could be the same number, 25 and 25. I mean, it doesn't necessarily say that they have to be different. Or they could be some decimal equivalent like 0.5 and 49.5. But what the real kicker here is that this quality too, that the product of these two has to be a maximum. That means that x times y has to be the maximum possible value. So if you start off with just this seems really insufficient. But let's actually take a step here, and if I'm coaching you a little bit on how to do this problem, what I'm going to ask you to do is to get the y by itself. Now let me show you why, because if I can get the y by itself by subtracting x from both sides here, so now I have y equals 50 minus x. I also could have wrote that negative x plus 50. I can now take this equation and substitute it using the substitution stuff we learned back in Unit 7 and plug it in for this y. So now what I have here is I have x times the quantity of 50 minus x, and I'm supposed to find a maximum value based on this information. Now if I distribute the x, using a little arithmetic, here's 50x minus x squared. I'm supposed to find the maximum based on this equation. Now, I know you probably never set anything equal to max, but what I'm going to do is maybe plug this into y1 or any part of the calculator and find out where the maximum is. Now, since this is a quadratic with a negative x squared, it's going to be a downward opening parabola, and its maximum is going to be at its vertex. And what I know about vertex is that the x coordinate of that vertex is going to be negative b over 2a. This is half of the part of finding an x and y coordinate at that vertex of negative b over 2a and f of negative b over 2a. Now, in this equation, my a is going to be negative 1, and my b is going to be 50. So if I go negative b, so this is negative 50, divided by 2 times a, I get an answer of negative 50 divided by negative 2. So my answer for that x value, x is going to be 25. So at 25, I am at the maximum height of this parabola. So my number is 25. And if I go 25 plus y equals 50, then my answer for y is also 25. Now to expand on this a little bit, remember how I said I need two numbers whose sum is 50, okay, I got it, and whose product is a maximum. Now knowing a little bit about geometry, if I have a two-dimensional object and I want to maximize its area on the inside, the most optimized area on the inside would be a square if I'm stuck to polygonal dimensions. So a 25 by 25 inch area object is going to be the biggest on the inside. And I think it's 625 if I think of that correctly here. 25 times 25. But I digress. What I'm saying is that this is the most maximum area that you can make with two numbers that add up to 50. All right, now you might now have just thought to yourself like, wow, I could have done this whole thing if I had understood that from the start. Can I just cut 50 in half and get 25? Which, yeah, you could have if the numbers were a sum, but now for the second problem it says find two numbers whose difference is 20. So my x minus y equals 20. So now I can't have the same number for x and y because 10 minus 10 is 0. And now we have to think of some combinations to make 20, and whose product is a minimum. Wow, okay, so this is x times y equals min. All right, well, this is going to be interesting here because we're going to find probably that x is going to be positive and y is going to be negative or vice versa. So let's continue working from the previous problem here. Let's get the y by itself. By subtracting x from both sides, I now have on the left and right hand side a negative y is equal to 20 minus x. And I'm going to divide everything by negative 1 to get rid of the negative in front of the y. So y is equal to negative 20 plus x. And I can rewrite that if I want to using the commutative property. So this is x minus 20. Now I know that this is x minus 20, so I am going to plug that in for y. So now I have x times x minus 20. And I'm going to try to find the minimum of that function. So this is x squared minus 20x is equal to some minimum. And again, instead of doing that, I can plug this into y1 of the calculator. And what that's going to give me is some smile. And the smile is, the reason why I know it's a smile, because the a value is 1. And that is going to have a vertex that's going to be at the minimum of that parabola. And to find that x is going to be negative b over 2a. Now my b is this number here, 20, which since it's negative b, it'll be negative 20, divided by 2 times a, which is 2 times 1. So that is going to be 2. So I'm going to have positive 20 over 2. So my x value is 10. So yeah, I mean, we did cut that in half, but you'll notice that 10 minus y makes 20. That y can't be 10 either. So to find my y, what I'm going to have to do is plug my 10 in for x. And again, this little space over here on the left is to figure out what the y is. Okay, and I'm going to subtract 10 from both sides. So negative y is equal to positive 10. Then I divide both sides by negative 1. Y is equal to negative 10. So my final answer is going to be that x is equal to 10. And y is going to be equal to negative 10. This is the two numbers whose difference is 20, because 10 minus 10 is 20. And the product of these two numbers is the smallest number possible, because if I multiply these together, I get negative 100. Now, I want to show you this on the calculator, and I'm going to click all this off here, and again, show you that I could have typed in the equation. And the equation in this case, let me turn this on. The equation in this case is going to be x squared minus, whoops, I wrote xx, x squared minus 20x. And then I can hit zoom 6 or graph, but you're going to see that it actually doesn't show up. So we really have to kind of like balloon out a little bit and see, oh, it should be a minus? Yeah, it should be a minus there. We're going to balloon out a little bit and see where this hits the minimum spot. So let's do a little window adjustment. So our x minimum and x maximum seems to be right. Let's go to 20 though. And my y minimum should go down much lower. So let's go down to negative 100. All right, so here's our graph. And there's our minimum. We can actually use the second trace command to find that minimum, option number 3. There's our left bound, and move to the right. I just have to be on the right hand side where I see my little cursor, hit enter, and I can guess where it is in the middle if I want to, and hit enter, and the calculator will come up with an answer that at 10, where x is equal to 10, my y is going to be at negative 100. I'm going to be actually using the calculator quite a bit on the next 4 problems to show you that not only can you use negative b over 2a, but you can also use your calculator to figure that out, as long as you're willing to fix the window. Let's click back to zoom 6 just to get back to a normal window, because for the next 4 problems, the window is going to need to be fixed if you're going to use your calculator in addition to doing some of the work by hand. So let's do some applications. So there's the height and feet of a rock thrown straight up is given by this function. And this is negative 16 is an approximation of negative 16 or 16 feet per second of the force of gravity, and the velocity of the object is 78 feet per second. Negative 16 feet per second squared of gravity, and then 78 feet per second. All right. So I'm not a physics teacher, so if I botch some of this up here, please forgive me. I'm just going to try to do the best I can. So what I'm going to do here is talk about finding the maximum height. Now, you can use negative b over 2a, and this is going to find our x value, or how high, or when that object is at its height. And to figure out the actual height, we're going to plug that back into the equation of f of negative b over 2a. All right, so this is going to give us our x and our y. So I'm going to start off with our negative b over 2a, and our b in this case is going to be our 78. So this is going to be our negative 78 divided by, in this case, 2a, right there. So this is going to be 2 times negative 16. And if I do this correctly, I get an approximation of about 2.44. So roughly 2 44 hundredths of a second. That's where we will find the maximum height of that rock thrown straight up into the air. Now, to get my f of b of negative 2a, I'm going to plug that 2.44 into the function. So this function is going to be negative 16. So gravity at 2.44 seconds plus the velocity acting on the object at 2.44 seconds is going to give me an approximation, if I type that into my calculator, of 95 6/100 of a feet in the air. So let's actually take a look at this on the calculator, remembering that it would be in approximately 2.5 seconds and approximately 95 feet in the air. Let's see how the calculator would actually help us get this answer. So, what I'd have to do is go into my y equals and type in this equation. Please note that that's a negative 16t squared, so you'd type in negative 16x squared. And it would be a negative, not a subtraction sign, plus 78x. So then what I do is I'm going to then hit graph. And remember I said that this hit the ground at roughly, or hit at maximum spot at roughly about 2.5 seconds and at about 100 feet. So what I have to do is fix my window. Instead of going up to 10 feet in the air, I'm going to have to go to 100 feet in the air. And there it is. There's my parabola that recognizes the height of the ball over time. Now I am going to use the second trace command, and I'm going to find its maximum 4. And I go on my left bound, kind of close to the top of the parabola, hit enter, and then on my right bound, hit enter again. Guess, take my cursor back to the middle, and again it should be about 2 44 hundredths of a second, which it will at its maximum, and a y of 95 6/100 at its height. So with the question asking find the maximum height, then we want the 95 6/100 of a feet, or of feet, into the air. So that is a good physics problem. Let's do the next 3. So here's the second one here. The height in feet s of a ball thrown upward at an initial speed of 62 feet per second from a platform 40 feet high, so now we have a part C in this problem, is this function. And note, gravity is still here at the beginning. Now, where t is time in seconds, find the maximum height. Okay, so this is the same thing again. We're going to use negative b over 2a. We're going to do that for the negative b over 2a. We're going to do that for the time at which that, in this case, ball would be at its most high spot. And the negative b is going to be negative 62 divided by 2 times a. In this case, it's 2 times negative 16. And what that is going to give us, if I do this correctly, type it in on my calculator, approximately 1 94 hundredths of a second, so roughly around 2 seconds. So now what I'm going to do is plug that back into the equation of s sub t. So this equation at 1.94 seconds, we're first going to have to figure out what gravity will do here and then the velocity, that initial speed of the ball at almost 2 seconds, and then we're going to add 40 feet based on the platform that we started it at. And this is going to give us 106 hundredths of a foot in the air. So this is going to be right over 100 feet. So if I go to my calculator to test this, roughly about 2 seconds, about 100 feet in the air. So, and you'll note that this is a lot like the last problem, but a lot less force on the ball, but did give it a little bit of help by being higher up from its initial heights, was 40 feet also in the air. So that had to get factored into the problem. So let's go take a look at the calculator, and let's go type in the equation. And notice my graph is still around 100, so that's still pretty good. So here's my gravity, and it's going to be 62 instead of 78. But again, we're going to add 40 to that. Let's go and hit graph, and you'll see, whoops, hit graph, not table. And you'll see that there it is. But, you know, the pixel does go a little bit off the screen, but that's okay. When I go to my trace on the maximum side, here I am on the left. I'll just hit enter. I'm going to go scoot over to the right. It's going to take its little trip around the parabola. Hit enter and enter again for the guess. And it does land around 1.94 seconds at a height of 100.06 feet. So, yeah, the calculator really does a great job as long as you're willing to kind of mess with the window here so you can actually see your parabola very well. It's a good idea. Now what we're about to do is talk about a rocket, and this rocket is going to be a lot of additional force. I mean, look at that. I know there's still gravity on it, but look at that, 325. I mean, that's so much more than what we just had. So this thing is going to fly. And notice it says after how many seconds does this rocket meet its maximum height. See, I don't even care about how high the rocket's going to be. I just want to know what it's going to be, like when it's going to reach its maximum height. So this is just negative b over 2a. I don't even need the second half of the equation. Now I'm not asking for you. I'm not asking how long will it take to be in the air. So negative b, now this is our b here because this is the number in front of the variable without the square. So this is negative 325 over 2 times a, and the a in this case is negative 16. So we have negative 325 divided by negative 36, which gives us approximately 10 and 16 hundredths of a second. So after 10.16 seconds, this will be at its maximum height. Now for fun, what you can do is you can find out when that parabola is, because that intersection is the symmetrical point about when this would be. So this is about 10.16 seconds. So roughly about 20 seconds here and 0 seconds here, you'll have your part of the problem. So, I mean, let's just actually turn on our calculators and figure that out, right? So I can turn on the calculator. If I really wanted to find out how tall it was, what I could do is I could type in 325 and then put in the time of how long, put in the time of how long it would be in the air, and minus 16, 10.16, quantity squared. It's going to be over 1,650 feet in the air. So if I'm doing the window for this thing, then my x-min and my x-max, now remember it was maxed out at 10 seconds, so I would need about 20 seconds on the clock, and we're going 1,700 feet in the air to see that maximum at about 1650. Whoops, screwed that up there. My y maximum, that didn't seem right. Let's go back and look at my equation. Oh, shoot, I had the wrong equation in. Here we go. I forgot to change my equation. 325x minus 16 x squared. And then now you can see that it will hit that 1,650 foot mark at roughly 10 seconds. And then we would have our object hit the ground right around 20. We can use the maximum command here, option number 4. Here's my left bound, nice on the left side of that parabola. Now all I have to do is just get a little bit on the right hand side, hit enter again for guess, and you'll see that I get that answer just like I did when I used negative b over 2a of 10 and 16 hundredths of a second. That's when it reaches its maximum height. And there's the actual height of it right there. All right, so for our final problem, our final application of business, is there's a manufacturer of DVD players, and he believes that the revenue that the company receives is related to the price. So here's the function. The function is that we've got 50p minus 1/4 p squared, and you know, I'm not going to try to explain what all that means, but you can kind of see that, you know, if something is too cheap, they're going to sell a lot of them but not make a lot of money per item. And then if it's too expensive on the other side, that no one's going to buy that item at that price. So what you're looking for is you're looking for that value right there, that sweet spot where you can charge them more and make the most profit, but not go too far on the other end where no one would buy your object. It's, you know, imagine that you really wanted to see a concert and the tickets, you know, were way too expensive, like let's say $2,000 a piece. Well, no one's going to go because they can't afford that. Or on the other side, if the concert was like, you know, $1 a piece, the band won't make any money because all that money is going to be then spent on security and stuff like that. So right in the middle is the sweet spot of buying something. And if we're just trying to find the price that will give us the maximum revenue, this on the x-axis is the price, and the revenue is going to be on the y-axis. So all I need to do is find that x, which is negative b over 2a. If I plug that into the calculator, I could figure out what the revenue or how much money I'm going to make, but I just really am trying to find the price here. So this is my b, and this is my a. The a is in front of the squared variable, and the b is in front of the non-squared variable. So I have negative 50 divided by 2 times negative 1/4. So this is another way of saying negative 50 divided by 2 times negative 1/4 is negative 2/4, or negative 1/2. And negative 50 divided by 1/2 is like skip, flip, multiply, divided by negative 2 over 1, which is the same thing as multiplying by negative 2. So $100 is where I would have my sweet spot. $200 would be too much for a DVD player. $0 would be too little because I wouldn't make any money. So in this parabola between 0 and 200, $100 gives us the most amount of revenue. And if I wanted to figure that out, like how much money would I make, I would go 50 times 100 minus 1/4 100 squared, and that would give me my revenue for the price of $100. And the best way to do that would be, well, type it into the calculator. So let's go and do that. I know I'm kind of going for extra points here. I'm not actually was required to do that, but you know, why not? Well, let's figure out how much it's going to be, and let's just do it here straight up on the calculator. 500, whoops, not 500, 50 times $100 for the DVD player. So that's my revenue, the positive part. But you know, the more we charge, the more people are possibly not going to buy it. So that 1/4 x squared. So in this case, I'm going to have my 100 squared, like so, and there. I'm going to make $2,500. So if I go from 0 to 200, let's go by 50s here, so you can kind of see the breakdown. And my y minimum is going to go from, let's see, I had to go to 2,500, so I'll start this at negative 250. I'm going to go to 2,500 by 250s, why not? And let's go take a look at that graph. There's our profit. Oh, shoot. What did I do now? Did I put the right equation in? No, I keep forgetting that. You got to put the right equation in, or else you won't see the correct curve. Well, you think I would have learned the first time, right? All right, so there's 1/4 x squared, and then there you go. There's your perfect, beautiful curve, which basically starts at $0, hits its maximum at $100, since the window was going by $50 pieces. So this is if we charged $0, $50, $100. There's our peak profit, $150, and $200 there. So again, just showing you a little bit more, showing off with the technology. And yeah, we could find our minimum using the trace command here as well, but we already did it on the equation. Well, thank you for watching the story problems here. If you have any questions, let me know. Thank you for watching.